All right, let's knock out 5 to 8 while we're at it here. Again, the same approach. I'm trying to get to where I have something where it says x is equal to something. And then I need to do the same thing to both sides, okay? So I want to try to isolate, I want to get x by itself. So I need to undo all the operations around it. I've got subtraction here, and I've got multiplication. So if I add 3 to both sides, I'll have negative 2x. Whoops, let's see if I can fix that. There we go. That should be okay. Okay, so what was I saying? I'm going to add 3 to both sides. So I'll have negative 2x is equal to, if I add 3 here, I will have only negative 16, right? Now, I want to undo multiplying by negative 2, so I need to do the inverse operation of multiplying by negative 2, which is dividing by negative 2. So if I divide by negative 2 here, I will end up with x, right? X is equal to, and I divide negative 16 by negative 2, a negative divided by negative is a positive, so positive 8. Let's just double check that. Negative 2 times 8 is negative 16, and then negative 16 minus 3 is negative 19, so that one worked. Okay, moving on. All right, so here I want to end up with x, so maybe something is equal to x. I've got some subtraction, and I've got to undo the division, okay? I can undo in any order, but from what we've seen, if I add 11 here, I can do that first. So if I add 11 to both sides, I undo the subtraction. This is going to be 2 now, equals x over 8. And now I want to undo the division, so I multiply both sides by 8. Okay, so then I'll have x. And this is 16. So I can rewrite that as x equals 16. Again, I said in the past we didn't have to do that. And I'm just going to check as always. So if I have 16 divided by 8, that's 2. Negative 11 plus 2, we know is negative 8, so that works. Okay. Again, isolating here. This one's, looks like... So, I've got, really if you have a fraction that would be division, I can undo the division first, but I think it's fine to just subtract 7 from both sides because I don't have any other fractions here. So that would be negative 2/3 x equals 1. Okay. And then I'm going to undo the division first. This is multiplication and division. So if I multiply both sides by 3, I will undo that division, the denominator part. So I'd have negative 2x equals, and if I multiply this side by 3, I'll have just 3. Okay, now I've got multiplication to undo. So I'm going to divide by negative 2. So x equals 3 divided by negative 2. Really, that's, that negative sign could go on top, it can go on the bottom, it can go on the outside here. It's negative 1.5 as a decimal. It doesn't really matter where we put that negative sign. I think the best place to put it might be, let's just put it on the outside. But it doesn't make any difference. We don't usually see it in the denominator. All right, check that real quick. So if I was to multiply by negative here, 3/2, that becomes negative 6 over 6, so negative minus a negative 1, okay? So minus a negative 1 minus 1, that is 7 minus 1, 7 plus 1 is 8. So that does work out. Now here's the one that will put you in a little bit of a pickle. Because if you think about, we've got a quarter here. You know what? If I subtract a quarter here, I guess it could work because I have a quarter over here. So that would be 2 quarters. But we've got then this half here. One thing that's really handy, and I will model that from now on, is when you have a bunch of fractions, we can think of that as division, okay? So how do I undo division? We know we multiply. So if I multiply by 4, I undo the division here, okay? If I multiply by 2, I undo the division here. And what I want to do is I want to find a number that would undo all of the fractions or all of the division, okay? So how I do that is I look at the largest denominator, and I'm going to try to find multiples of it that would undo all of the denominators or all of the division. So I've got 4. If I multiply by 4 here, that's going to undo that division. Now I got to see, is 4 a multiple that works for the other denominators? Is 4 a multiple of 2? Well, yeah, it is. So if I use my lowest common multiple of all the denominators is 4. So I'm going to multiply everything on the left side by 4 and the right side by 4. What am I going to do? I'm going to cancel that division. So then I'll have 1. 4 divided by 2 is 2. So minus 2 times x, that's 2x. 4 divided by 4, that cancels that out. That's just 1, so it's equal to 3. Look at this. Now I don't have any fractions by simply multiplying everything by a common multiple of the denominators, the lowest common multiple. I could go and multiply it all by 8, but that just gives us numbers that are a little bit bigger that we don't need. Alright, so now I'm just going to isolate x, so back to something simple. I subtract 1 from both sides. Negative 2x is equal to 2. Divide by, because I want to undo the multiplying by negative 2, so divide by negative 2. X equals, and that's going to be negative 1. And that's it, folks.